Which part did you miss? So I'm at the reaction between the hydrogen ion and the hydroxide ion. So the two of them, they react with each other to form water. Then this process is called neutralization. Hmm. So, so base and alkalis will react with acid, you get salt and water. So the ionic equation, this one is the ionic equation for neutralization. So they will always ask for what is the ionic equation for neutralization. It is always this answer. So at the end of the reaction, you will form a solution which is neutral. That's why it's called neutralization. So because that reaction is the ionic equation for neutralization is always that equation. That means the answer is always the same. So answer is this one.
What is a neutralization reaction?
Yeah. So which one is a neutralization reaction?
What is a neutralization reaction?
What is a neutralization reaction?
Yeah.
Okay, so let's go back then. Okay, so this is the section on neutralization. So it means that you have an acid or a base and an alkali, then two of them will react. After the reaction, you'll get salt and water. Then, of course, this in ion form, right? That would mean that the acids they produce H plus ions, and this alkali stuff will produce OH ions. So the SH plus ions from the acid will react with the OH minus that comes from the alkali or the base. Then the two of them combine and give you water. So these two chemicals, they react with each other, you get water, and your end result is that a neutral solution will be formed. That means whatever you have at the end will be neutral. Meaning that if you take a universal indicator and you test it, you will get pH 7. So neutralization means a reaction where you have acid and alkali together and eventually you get salt and water and the overall solution is neutral. Okay?
Yeah.
So
is it there's more than one? Is it there's more than one indicator, or there's only one indicator?
yes, there's more than one indicator. So
Then why that's who said
did I
in
have
one
the indicator here?
Huh.
Nah, so I've gone back to this one. This one is about indicator. You have the pH scale. Then the universal indicator is the one that change color all the time. So every pH will change color. So you have a variety of colors. That's one indicator. Then there are other indicators like methyl orange, phenolphthalein, screen methyl orange, litmus, bromothymine blue. All of them will change color at a certain pH range. So that means methyl orange will be red in acidic and then yellow will be when it's alkaline. So other indicators, they will have other colors and they change color differently. Like what is indicated in this slide? Question?
That means in one indicator, one solution of the pH, that two is one higher than in another indicator, it's another color.
Yes. So that means pH 2 in methyl orange will be red, but pH 2 in phenolphthalein will be colorless. So it will be purple if it's in screen methyl orange, and it's red in litmus, and it's gonna be yellow in bromothymine blue.
I thought litmus paper only have red and blue.
Litmus is only red and blue, yeah, litmus.
Then I thought indicators have red, green, blue, indigo, violet.
That is universal indicator, which is this one. This is the universal indicator. So it will be red in 0 to 4, then it become orange in at 5, yellow at 6, green at 7, then bluish green at 8, blue at 9, bluish purple at 10, and then purple at the other end. So indigo is a shade of purple. So this is the one that changes color all the time. There'll be red. Red when it's strong acid. Then you'll be indigo, violet, whatever you call it, purple, any shade of purple. Then you'll be alkaline. Then it will be green color when it's neutral. That is universal indicator. Then the other indicator you probably have is litmus. And you may also have either methyl orange or phenolphthalein. But there are many, 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 many indicators, which will then come up, which will bring you to this kind of question where they say you have two indicators and then what color will they show at a specific pH? You see, question. So neutralization means you have acid base, they react, and then you get a neutral solution. Which equation best represents the reaction between an acid and an alkali? Yeah, because that comes from no matter what, right? Whichever reaction, whichever neutralization reaction, whatever chemicals you use, neutralization is always H plus OH gives you water. So A is the answer as well. Okay, this is another one. You will notice that not all the state symbols are there because the AQ that is written down there just means that it's dissolved in water in solution. Then concentrated sulfuric acid means it's very high in sulfuric acid. Then C, right, there's an AQ in ammonium hydroxide. That one is just to indicate equals ammonia. Okay, let's see if the answer is correct. Okay.